Hey guys, welcome to my new, I guess I haven't named this yet, but it's essentially the how to make a programming language tutorial series again. Now, if you haven't seen, I'd recommend checking out part one. I think it was part one, maybe part zero. The first part of my previous series where I made just a simple interpreted language using Python. You don't have to watch like the whole series, but I think that first video where I go over how a programming language works is going to be very useful for this. So this is going to be pretty similar to that series, but we're going to be making a more in-depth language, and in this time, I think we're going to be making a transpiled language. We might end up making it also interpreted, but I think I'm mainly going to make it transpiled to C. Just to show you guys how a transpiler works, and because a lot of languages will end up actually being transpiled, and it's better than making like a compiler from scratch. So as you see here, I just have an empty directory called YouTube lang. And for this project, instead of Python, this time we're going to be using Kotlin. Now, I've done this in Python, C++, and Kotlin. The issue with Python is it runs too slowly when you compile things. Your compiler is going to be very slow if you write it in Python. Then I moved to C++, which admittedly was very quick, but it ended up becoming unmaintainable because you just needed so many header files. So I've decided to go to Kotlin because, well, I really like a lot of the syntax. It's essentially Java, but it takes away a lot of the stupidity of Java. But you, following this tutorial, can use any language you like, so long as you can sort of convert it in your head. I'll try to explain some of the more Kotlin-specific features when I use them, but it should be mostly understandable. This is also going to be a bit more of a natural paced tutorial, so it might be slow in some parts. And I don't really have it fully scripted. In fact, I'm just going off the top of my head, so hopefully it ends up pretty good. So if you want to exactly follow along with me, the only thing you should need installed is Gradle, and it should be roughly new. It probably doesn't have to be this exact version, but it should be new enough so that you get the menu that I'm about to get. If you're doing this on Windows, God help you. Hopefully you can figure out how to make it work for you, but there's going to be some things I do that are very Linux or I suppose Mac OS dependent. So the first thing we want to do is actually create our project, and we have to run Gradle init. And if you have a version of Gradle that's way too old, you're not going to get this menu, so that's why it needs to be slightly new. Now what I'm going to do is I'm going to make an application, and you can just type the numbers in for your selection. I'm going to be choosing Kotlin. I want a single application project. I choose to use Kotlin for the build script as well. It doesn't really matter. Project name, that's fine. Source package, I'm just going to call C, because the language that we're making is going to be a subset of my language called C. And it's a horrible name, I know. It's like at the same time, I don't want to apologize for it, but I also really should. So now if you look, we have just this sort of structure that's generated for us. Let's check out what's an app. You basically have like a long list of things. You have a main where all your source code's going to be Kotlin, and then like there's your sort of app file, which is like the main thing. There's a lot of stuff that Gradle makes, but you don't have to worry about too much of it. Using Gradle is just convenient because we'll be able to build this app and it will work on like any operating system. And the cool thing is if you're developing it, especially with a team, all you need is Gradle installed and it will install Kotlin and all the other dependencies for you. So my editor is going to be Vim. I'm not good at Vim. I'm very new at it, so it's going to be very inefficient, but you can already see I've customized it somewhat. I'm also going to do things like this where I'll navigate in one at a time so you can kind of follow along where we are, although you can also see at the bottom of the screen exactly where we are. So if we open up our app so far, it's just minimal, it's just a hello world. I'm also going to be using this drop-down terminal so that I don't have to exit Vim. So let me go into Kotlin/YouTube lang. And if we look, there's a Gradle W and a Gradle W.bat. If you're on Windows, you want to be dealing with Gradle W.bat. On Linux, we want to be just dealing with Gradle W. And the W stands for wrapper. It's essentially a wrapper just over Gradle so that it works on your specific operating system with your setup. So what we can do is we can run Gradle w build, and this will just build the project and make sure that everything's working. And then we can do Gradle w run, and we get hello world. Now, if you run into trouble here already, then ask in the comments and I can try and help, or, do your best research. But this should, in principle, work because we haven't done anything except make the project. So what we can do is we can actually get rid of this entire app class. Now, what I haven't mentioned, I'll just clean this up. Gradle is also really good for allowing you to do tests, like unit testing, but in our case, I'm not going to do that. I'd recommend that you probably do, but I'm not good enough at unit testing to actually, showcase this. So if we go back and I look at, I guess there's nothing, I have to go back and go up. So if you're in the app source directory, there's a main and a test. In tests, you'll have an app test. So in order to make your thing build, you have to get rid of this now. You can either clear it out, but I think what I'm going to do is just delete it. And then if I go up, this should just be empty. So now that we've gotten rid of that app class, which is expected for that test to run, and now that the test is gone, it still runs correctly. All right, so this is a good start. Let's go back into here. Now you see on this side, I've already sort of built all the code that we're going to need. At least for this first part, I've made the lexer. The lexer is, of course, the tokenizer, the thing that will take our source code and produce a list of tokens. So what I'm going to do is I'm going to come back out here. I guess I didn't need to do it here. That's fine. I will make a directory called test just in the general project folder. And I'm going to create a file.lang. Now you can use, well, I suppose .c. You can use whatever extension you want for your language. But essentially, you're going to have source code, which is, in my case, a file.c. And in there, we can put certain things that can be transpiled eventually. And there's nothing in there, so we don't have to worry about it. Now you'll see I have a lang.bash. This is just a simple script that is going to be just for convenience. So where exactly did I put that? That's just in here. So if I make c.bash, I guess, I can just write a simple bash script. And all this is going to do is it's going to build the Gradle project. It's then going to run it, supplying it some arguments. And then we're going to print out a new file, which will be a C debug, like that. What I like to do is I like to actually see what my compiler's doing and see the list of tokens and the abstract syntax tree and stuff. So what I do is for every file I compile, I produce a debug file that just has everything in it. Now, the arguments we're going to provide, our program itself is going to take, well, at least 3 arguments. It's going to have a string of options, which in the future will add more options, but the first one I have is a D for debug, which means produce this. The next is the output file, or the output folder that we want to write the code to. That right now is the test directory, but notice it's a // because we have right now we're in YouTube lang /cbash, and the test file is in YouTube lang. But when we run our program, it will start in YouTube lang /app, so we have to go out one directory and go to test. That's just temporary because we don't have a good way to interface with the program yet. In practice, you would build it and then deploy that built program, and so it's going to be slightly different in the future. But for testing purposes, this is all we sort of need. And then the way I want this to work is it will take any number of files to compile after. And in the future, this script will be a lot bigger. I've written a bash script that will allow us to essentially, you can call the bash script with basic arguments, things like -d or -o is equal to this output directory. And then you can give it like directories, and it can figure out all of the files inside of those directories that need to be compiled. And then it itself will essentially call Gradle run for our project. But if we go back now to app.kt, what we can do is we can come in here and say args of type. Suppose I want to actually look exactly app.kt at what we're going to be having. In Kotlin, you declare types on the right side. So it's args of type array of string. We don't have to worry about the run blocking thing yet. So right now we're just taking in an array of strings as arguments. And now we can parse those a little bit. So like I said, the first thing is the options. The first string, in fact, will be the options. Then an output directory. And then everything else are our file paths. And in Kotlin, you can do .drop. And this is like in Python if you were doing args from to ... something like that, where it will be everything in that array from 2 upwards, basically. It just drops the first 2 things, but it then produces a new array. Also, you notice I don't need to specify that this is an array of strings. The types are all inferred. And also in Kotlin, you have val and var. Variables can be reassigned after vals cannot be. And then you see on the right side, eventually we're going to do some jobs and things so that we can compile one file. Well, we can compile all the files at the same time asynchronously, which I don't know if that's necessarily the best approach, because if you're compiling, say, 100 files, you might end up with like 100 threads, depending on how job is implemented. So, but the reason I'm doing that is because in my language, C, I have like a linker which will sort of link imports. Like you see in the top right there, we have imports from like Kotlin X coroutines and stuff. My language will have like essentially a linker, but it will happen as source code. It like links source code instead of like bytecode. So what that means is all the files would have to be transpiled, and then they all have to wait until they reach the same point, and then they can continue, which is why I chose to do them all asynchronously at the same time. In our case, it's just going to probably speed things up because we're only going to compile, I mean, in this project, probably just one at a time. But this is just to kind of show you what you can do. But right now, let's just make sure that we actually have our arguments. Now, this is one of the best features of Kotlin, in my opinion. You can do a $sign followed by a variable name. And this is string interpolation, so it will create a string with the value of options inside of the string. It's similar to f strings in Python, or if you just did like %s, comma, options in another language. But it's just a very clean way of doing this. And in fact, our language will end up doing something very similar to this. You can also use braces like this to print out whole expressions. But if it's just a single identifier, you don't need braces and you can just do options. So I'll just print these out separated by commas. And then if we come and run, well, first, of course, cmod plus x to make our bash script executable. Then we can run it. Okay. So it seems to have worked. You see right here, it printed out the arguments. And the arguments we gave it is -d, the output directory, and the list of files, which in this case is a single file. Then you see it errored because we haven't produced a file.cdebug yet, which is fine. But so yeah, things seem to be pretty good. The next thing we need to do is we have to go into, I guess I'll do this sort of directly so you can see better. From our app, we want to go into our build.gradle.kotlin script, and we have some dependencies that we need to change. Definitely not very efficient to Vim yet. Okay, back. You see by default, this should be essentially the default. Your version might be slightly different, but that's not too big of a deal. We have some test dependencies that we no longer need. If you are going to be doing unit testing, then you should probably keep those or use whichever ones you like. But we have to add 2 more dependencies. One for Kotlin coroutines, which will allow us to use the like multi-threading job syntax that we had before, or will have. And it's org.jetbrains.kotlinx, kotlinx coroutines core 1.5.2 is the version that is probably most recent, at least at time of writing. And Kotlin reflect. I don't remember precisely why I use this. I think it's just so I can talk about K classes and stuff. It probably won't be useful in this episode, but probably in future ones. Let me just make sure I feel like I misspelled implementation, but I think I'm fine. So these should essentially be what we need. Now if we go out, if we run cbash, it will rebuild it, and it should auto download all those dependencies. So you see that everything seems to be working just fine. Right, control, I need to remember control tab to get over here. And there's just a few more things that I need in here. And then I think I'll probably just keep these episodes pretty short and concise. So if we go back into app.kt, we can now import kotlinx.coroutines, and we can import everything from there. And now in order to make this work how we want it to, essentially what we're going to do is exactly what's on the right. We're going to make a bunch of jobs, which is we're going to construct an array list to store them. And I'm choosing to use this so that we can specify the size because of efficiency, essentially. If you're familiar with array lists, they'll dynamically change their size. But that's kind of inefficient. If you know exactly how many items you want to store in them, you can just initialize it to that size and not worry about that, because every time it has to duplicate, it copies memory and it's slow. So we can just construct it with filepaths.size, which gets the number of items in the file paths, ergo the number of file paths we have, and we can just make one job per that. Now what we can do is we can loop through all of our source paths, and we can construct a job by using launch, and we give it a function to do. And we have to come down here, and we make a suspend function. Suspend essentially allows it to be asynchronous. And we'll have the function that will actually compile each file. And these are going to require the source path, which is a string, the output directory, which is a string, and our options string as well. For now, we can just leave that as is, but we can come back up here. And now each of our jobs is going to be able to compile a file. The file we're giving it is the source path, which is the current iteration of this loop, the output directory, and options. And then what we can do is we can add this new job to our array list. And finally, at the end, so that our program actually works, we need to pause the main thread until all of these things are done. So what we can say is jobs.join all. And this will wait for all of the jobs in that array list to be completed. This isn't good enough, though. We need to actually say something else. We need to use run blocking, because jobs.joinAll is an asynchronous thing. And in order to make the main thread wait, it has to be run blocking. So we can come up here and we can do this. And there's a lot of like higher level stuff that I don't fully understand about how this works, but I don't think you really have to fully understand. I think this is good enough. It's like declaring a function as async in JavaScript, from all I can tell. And that allows us to do this jobs.joinAll, which will wait the main thread until all the jobs have finished compiling. And now, what exactly is the compilation process? Well, we don't have to worry too much about that yet, because we don't actually have our lexer. But what we're going to do is in here, we're going to like run stage 0, which is our lexer. Stage 1. And then we'll run stage 2. Parser. And essentially we just have multiple stages, and you yourself can add intermediate stages if you have certain things you want to do. For instance, if you have a robust preprocessor, you can do that before you do lexing if you want, just like C. I always have to specify which C I'm talking about. You can do that, or if you have other intermediary steps, you can add those in as well. But basically what we need is just a convenient function that allows us to run these stages. Now, before we actually implement this, you see on the right we have this thing called faults. And if I go ahead and I open up this, what I want to do, if I go back out here, is in this directory in our like C package, I want to create a faults.kt file. And I'm going to declare that this is in package C, and we're going to make a class called faults. The purpose of this class is to hold all of the errors and warnings that we may get as we transpile our language. Because as you know, sometimes you run into syntax errors or things. And it's good to handle those so that, well, it's specifically good if you're making a language to provide feedback from your compiler. I mean, imagine if you were writing a language and you made a mistake and the language just didn't work and it never told you anything. It's kind of like how C or C++ works, am I right? So what we're going to do is each of our files and each of our stages, you could do this without using like object-oriented like methodology. I'm trying to keep that to a minimum, but I am keeping state as part of the data. And the reason for that is for asynchronicity, so that each file can have its own fault object, and then it can reference that object. Each file can have its own lexer, which has reference to that file's fault object, and then the lexer can throw errors from that fault. So what we can do is we can create a compiler failure, which is an exception, and we can just use this sort of as like a name more than anything else. I also want a public interface called component. And the purpose of the component interface is so that when we have things like tokens or nodes in our tree, they can be fault components. And what that means is we know how to actually like print them out as an error. So what they need is a tree string. They need a way to be marked so that we know exactly like, hey, we can say this token, that's bad, so let's mark it so that later we can handle the error with that. And then we have a get marked lines string. And this will be more obvious why we have this probably in the next video, but essentially we're just providing methods into this interface so that nodes and tokens can have to implement them. So then we can have some properties. We can give it a stage, which can change. I suppose warnings can actually be a value, but it's just going to be a mutable list of type string. It's going to be empty. So this syntax in Kotlin, if you're using a different language or are unfamiliar, there's functions called like list of, mutable list of, etc. that just create, it kind of does exactly what it says. We're just creating a mutable list of type string that contains nothing. If we wanted to make it contain like 2 numbers, it could do that. Although you wouldn't want to specify it's of type string. You could essentially do the same thing if you just made this an array list of type string. But I'm just choosing to make it mutable, a mutable list of, to sort of hide how it's doing it. I don't care what type of list it gives me, so long as it's some mutable list. And of course, we're using Java's sort of hierarchy of like list objects and such. So if you're familiar with that, then you'll know like the properties that these things need. Similarly, we need a mutable list of errors. So there's going to be different stages of faults. there's warnings, which are like, hey, you probably shouldn't be doing this, but it's totally fine. It doesn't actually change anything, so I'm just going to warn you that you probably should change that code. Then there's errors, which are like probably what you're most familiar with, where it's just like, this is not going to work, so I'm just going to add an error. But then there's things that are worse, which are failures. And so what a failure is, you notice how it's not a list, it's a single one. A failure to me is something that is so bad that we can't continue compiling. The thing with an error is, once you get an error, you can keep compiling. It might end up being wrong and you might get other errors for no reason, which happens frequently. But it's not so bad that we can't keep trying to look for more errors. Whereas a failure is like, we really need to just like stop and guarantee. Like, we just need to end it here because it is so bad and there's nothing we can do to fix it. You'll notice this is of type string, but I'm using a question mark to make it a nullable string. One of the very nice things about Kotlin is, if you know Java, you can run into null pointer exceptions all the time because everything can be null. In Kotlin, null is opt-in, meaning when I say this mutable list of type string, none of those strings can ever be null, or it will throw a null pointer exception. Or like, it just simply, the compiler itself doesn't allow you to do that. So you have to specify that you want a value to be nullable in Kotlin, which is a very nice feature in my opinion. Okay, so there's some like sort of weird things about Kotlin. One of them is going to be, if we want static members, the way we do that is, instead of like declaring something as static, what we do is we make a companion object. And essentially, every single object is going to have reference to this one, and you can access this one through like false dot, and you can get the properties in here. But this is essentially just a static property, just like in any other language, and we're doing this mostly just because there's no reason for every object to need this. We should just have one reference to it. And this is our stage map. So like I said, we're going to have a bunch of stages, and some of those are like lexing, parsing. In this case, I'm not going to be doing publishing, so transpiling. And I'm making them verbs explicitly because we're going to be using this for the errors in a moment. But basically, this is just a list of 3 words. That's all this is. Now we can make a toString so that we have an easy way to print all of our errors. This will allow us to simply do this, and then the toString will be called, and whatever we pass will be put into that string. So of course we can just make a string and then return it. And all we're going to do is, the string will start with all the warnings, because it should be the most crucial thing at the bottom, because that's where it's most visible. You know, like when you run the terminal, it will be the bottom that's right there. So we put the warnings first, and we can call, since it's a mutable list, we can join the list to string, separating each item by a new line. Same thing with errors, we can just append that onto the string. And then we can add our failure. Now, another thing about Kotlin, if statements are actually expressions, meaning they can return values, a consequence of that is they don't need a ternary operator like other languages. You can just use an if statement. So this could be, if you're doing this in another language, you could replace this with just a ternary statement. So essentially, if failure is null, we're just checking if it's null, then we should just add an empty string. Otherwise, we should then add our failure, and I'm just going to sandwich it between 2 new lines for the structure. I misspelt that. There we go. If we come over here, we can now scroll down and see the rest of this. We can make a private function called act, and this is just going to be like a general thing for each of our errors. It doesn't care what type of error it is. It's just a general way of doing it so that we don't have to repeat the code. So it will take in some component, which is why we made the interface. And then it will take a message and a severity. severity being warning, error, or failure, and it will return a string. And what we do is we mark the component that we pass in. We can now make the label, and the label is going to be the stage map at stage, which is going to return lexing, parsing, or transpiling, followed by the severity. So things that this label can be is something like lexing error, or it could end up being transpiling failure. Those are the types of strings that our label can end up becoming. That's just, I like to show which stage it failed in, mostly for my purposes as debugging. But it might also be useful to your user to know that as well, hypothetically. Certainly knowing if it's an error is important or not. And then we can simply return, we want the label followed by the message that we gave for the error, a new line, and then we can do c.getMarkedLines. And what that's going to do, eventually we're going to store every single line of the source code, and then we'll be able to know exactly which characters in that line are problematic, and we can produce something like this. So suppose your language doesn't allow you to add characters to a number, for example, and this is your source line. We'll be able to print out something like, I don't know, like line 5, and then, I don't know, we could do something like this, right? We'll be able to print that out to the terminal, something like that. That's what the marking is for. When we mark something, we essentially keep track of the position of that token, because every token will know its position in the line. And then we can mark a token, which will mark that position in the line, to allow us to produce these like symbols to say, yeah, this is where the problem is. And then you can print that out. And this is a pretty good way of handling things. The only issue is sometimes if things take up multiple lines, this system is limited, because it's very good for single line errors. Like, it's very solid for that. But when it comes to multi-line, you might want to engineer something a bit better, but it works pretty well, in my opinion. Oh god. Yeah. Alright, so that's our act, and then we can actually now use our act. And what we're going to do is we're going to make 3 new functions. The purpose of these is so that we'll be able to say something like lexer.false.warn to make a warning, or error, or fail. And I choose to make these verbs because it feels like an action, which is why I called the function before act. So we can make a warning, which will take a component and a message. And so instead of doing all that label nonsense, we can now just say, we can add to our warnings the result of act, see message warning. And the warning is the severity. You could also, I don't think I've said this yet, but in Kotlin, you can also just set a function equal to a value. And then you don't need a return type. And the return type will be the return type of the expression. And it's just a neat way of doing things. In this case, I'm not going to do that because the result of a list.add is like true or false, whether it was added or not. And I don't want warn to return anything, which is why I didn't specify a return type. And then we can do function error, which these are all going to be roughly the same. We can do errors.add, act, see component, see message, and error. And now fail is going to be slightly different because we don't have a list this time. We have a component and a message. And what I like to do is, like I said, when you fail, it should stop compiling. So this one's actually going to return a compiler failure. And we're going to set failure equal to act, see message, and failure. And it's just going to return a new compiler failure. Now, you could choose to just throw a compiler failure, but the syntax that I don't like to say false.fail, I like to say throw false.fail so that I know in the code when I'm calling false.fail that it's going to throw an exception. I like to explicitly have to throw, which is why I have this simply return an exception rather than throwing it here. Lastly, we need a finish stage so that every time we change stage, it can check if there's errors, basically. So the reason that errors work is because if you're lexing, right, if you're tokenizing, if you have one token that's a problem, you can just throw an error and that's fine. But once you get to the next stage of parsing, it's no longer fine. So if you have any errors, then you really need to stop the stage. So we can increment the stage, and actually, I'm pretty sure the code on the right isn't correct. It should only be if errors.size is 0. Because if you have warnings, it doesn't matter, right? So if there are no errors, you can just leave. Otherwise, there's an error, and we can throw a compiler failure to stop now. Unresolved reference compiler failure. Let me guess. Did I misspell it at the top? Compile failure. But yeah, that's pretty good. And so if we go back to our app now, we should be able to actually make our run stage. So since false is in the same package, we don't need to import it. And we can take in false for our stage. And we can take in a lambda function, which is going to return nothing. And everything that returns nothing in Kotlin actually returns what's called a unit. So we can just say this. And we want our run stage to return a Boolean, whether it failed or not, basically. So failed is false initially, and at the end we return whether we failed. And then we do a try catch. And now you're seeing why I'm doing this generic run stage rather than having to implement this for each individual stage. We have to run whatever the function is, and that's going to actually perform the code we want, like running the lexer. And then what we can do is we can say false.finish stage, like we implemented before. And so in func, we're going to run our lexer, for example. And we'll accumulate warnings and errors. If there's a failure, it will be thrown from func. And so we'll just get caught next. But if there were errors, that didn't happen. So what we have to do is we have to say false.finish stage. And that's going to increment the stage, but it's also going to check if there's any errors that were made. And if there are, then it should throw an exception. We can now catch either of those false.compiler failures. And now if it's true that we've failed, we can say failed is true, and then we can print out all of our faults. Now, since we're doing this asynchronously, the printing might not end up being in order, but I haven't found it to really matter. It really just as far as my experience has gone, it's always printed in the right order. But you might want to be careful with that in principle. So now we can actually create our, an example of a stage and why we set it up this way. So we can run our lexer, which is going to take a lexer, but for now, we aren't going to take in anything. Yeah, we can't take either of those because we haven't implemented it. But basically, we have our run lexer. And similar to before, where we had run blocking, well, what we can do now is, since in Kotlin, you can just set a function equal to an expression, how about the expression we do is a call to the run stage. So for now, we have to actually take in the false object. And then we can pass that into here. But next, it takes a lambda. And the syntax we can do is just this. So actually, that's what we were doing before with the run blocking. I really like this notation because it really looks as if we're making one function, right? But actually what's happening is we're setting run lexer equal to the result of run stage. And we're passing run stage a lambda function. I really like this. I think this looks very good. And so run stage is also going to return true or false. We'll worry about that in a moment. But so when we run our lexer, the first thing we'll do is we'll just say building name of file here, ... And then we can like make tokens, and we can like write the debug if the debug flag is actually used. So then we can come up here and compile file, and we'll end up making a debug file. But each file, like we said before, each of our sources or source paths will call compile file asynchronously. So each of them will have their own false object that we're creating here. And then we have a lexer. And then if run lexer, and we have to pass in our arguments, which for now is just false, then we return. Because what runStage returns is whether this thing failed. This is probably the least sort of readable, intuitive understanding. This is like the least understandable code so far, I think. But it's not too bad. It's just, if this thing fails, it returns true. And that just provides an easy way for us to stop compiling if there were errors. You could change how that works. You could negate it if you feel like that makes more sense, or you could change the wording so that it's like run lexer. Like just finding some way to word it so that it seems a bit better, but hopefully you understand exactly what's happening here. And that's essentially the process. We have this false objects that we can pass to each of our components, our stages. And then we can run each of our stages, and if any of them fail, we just stop compiling, which will then, they will have printed out all their faults. And yeah, I think that's probably good for now. I think we should probably try and run it to see if it actually works. We have a few warnings, but you see we get building name of file here, and that's it. I hope you don't run into errors, because I know the biggest problem with fault-tolerant tutorials like this is it just never works out. Like, they'll just write something and it will work perfectly for them, and then when you're following, you're like, why is it completely broken for me? I don't even understand. I don't even know what question to ask to help solve why it doesn't work. So I hope that this is working well for you. I hope it's pretty uneventful, just like it is for me. Chances are you may have mistyped something. That's kind of how it is a lot of the time. But anyway, in the next part, we'll actually implement more of our lexer. I think we'll probably be able to do the whole thing. Let me know if you guys like this newer sort of style to these tutorials. I'm trying to be a lot more in-depth, and it's a bit slower, but I think overall it's going to end up being better. So give me your feedback. I hope you enjoyed, and I'll see you in the next video.